Start by understanding what a pull-down resistor actually is. Imagine you have a signal line in your circuit that isn't always being driven by another device. If left unconnected, this line can pick up stray signals or noise, causing unpredictable behavior. A pull-down resistor solves this by connecting the signal line to ground, ensuring that when no other device is driving the line high, it stays at a known low logic state. This means the pin will reliably read as off or inactive, preventing ghost signals and keeping your circuit stable. Pull-down resistors are essential for providing a default state and avoiding floating inputs, which can lead to random toggling or false triggers. Why do we need pull-down resistors and where do we use them? The main reason is to prevent floating inputs, which can cause noise-induced false triggering. By defining a default state, pull-down resistors ensure that pins start low after a reset and remain stable until an active signal is applied. They are especially useful in circuits with push-button inputs, where you want the input to stay low until the button is pressed. You'll commonly find pull-down resistors in GPIO inputs for switches and sensors, enable or disable pins that need a default off logic, and in clock or reset circuits to ensure a stable startup. Essentially, whenever you need a reliable low-state, pull-down resistors are the go-to solution. Let's break down how pull-down resistors function in practice. There are two main states to consider. First, when the switch is open, the pull-down resistor provides a path from the pin to ground, pulling the voltage down to nearly 0 volts. In this state, the pin reads as low or logic 0. Now, when the switch is closed, it creates a low resistance path to the supply voltage VCC, overpowering the weak pull-down resistor. The voltage at the pin rises to match VCC and the pin reads as high or logic 1. This simple mechanism ensures that your input pin always has a defined logic level, whether the switch is open or closed, keeping your circuit behavior predictable. Selecting the right pull-down resistor value is crucial for reliable operation. The value depends on several factors: the leakage current of the input pin, the desired response speed, and power dissipation when the line is driven high. Typically, values between 1k ohms and 100k ohms are used, with 10k ohms being common. Lower values provide stronger biasing and are better for noisy environments, while higher values are suitable for low-power systems. It's also important to place the resistor close to the input pin and verify startup behavior with an oscilloscope to catch any unwanted glitches. Remember, omitting the pull-down or choosing the wrong value can lead to floating inputs, noise pickup, or wasted current. Wrap-up pull-down resistors are essential for ensuring that your circuit inputs, enable lines, and reset circuits have a stable default low logic state. The right resistor value balances leakage current, noise immunity, and power consumption. Always keep the resistor close to the input pin and adjust the value based on your circuit's needs, lower for noisy environments, higher for low-power designs. Avoid common mistakes like omitting the resistor or picking a value that's too high or too low. By following these best practices, you'll achieve reliable, predictable logic behavior and avoid those pesky ghost signals that can disrupt your design.